Modern artificial intelligence can consume hundreds of thousands of legal documents and pass the bar exam in a fraction of a second. Yet, if you ask that exact same cutting-edge system to snap together a piece of cheap flat-pack furniture, it completely breaks down. We have built servers that hold the sum of all recorded human knowledge, processing millions of data points in milliseconds. But those same systems lack the basic spatial awareness and physical coordination of an average toddler. We naturally assume that manual labor is simple and intellectual labor is difficult. Our society pays corporate lawyers far more than residential movers because we assume that legal reasoning is a much higher hurdle to clear. The data shows our traditional definition of intelligence is completely backward when it comes to operating in the physical world. This chart illustrates Moravec's paradox. Early computer scientists noticed a discrepancy. Abstract, high-level logic, like complex algebra, requires very little computational power to simulate. Conversely, basic physical movement, simply maintaining balance or grabbing an object, demands almost incomprehensible amounts of continuous computing power. This chart compares specific tasks to show exactly how extreme that jump is. Writing a creative novel is a relatively low hurdle for a computer. Hanging a door on an uneven hinge presents a deeply complex engineering problem for a machine. Millions of years of human evolution made walking and grabbing feel effortless to us. We do it without thinking, which gave us a massive blind spot regarding how mathematically complex the real world actually is. We do have robots building things today, but look at this pristine setup. It features a CNC machine cutting perfectly straight wood. It relies entirely on a sterile, predictable factory environment. A live construction site offers none of those guarantees. It is a chaotic, unstructured environment filled with unpredictable variables that change by the minute. When a human carpenter walks onto a residential job site, they automatically adjust for materials that have warped sitting in the sun, or foundations that have settled and are slightly off level. They compensate for these flaws instantly. Human hands process tactile feedback, instantly adjusting to knots in the wood. The messiness of physical reality acts as an unbreakable firewall. It protects blue-collar trades from the wave of automation currently sweeping through white-collar office jobs. The physical trades are highly protected from direct replacement, but they are not immune to technological evolution. The next step in the trades is the augmented artisan. This is a tradesperson who relies on their physical skills for the final execution, but uses artificial intelligence to handle strategy, design, and business management. Independent contractors can upload complex building plans, have the system instantly cross-reference those plans with local municipal codes, and accurately fact-check their material orders. Artificial intelligence will never replace the carpenter, but the carpenter who uses digital tools to eliminate their administrative overhead will bankrupt the carpenter who refuses to adapt. We are entering an economy where digital intelligence, coding, drafting, and complex math is becoming cheap and abundant. Because of that, low-level physical adaptability is becoming the most scarce and valuable skill on the market. Mastering the intersection between chaotic, unpredictable job sites and high-speed digital tools is the ultimate form of career security. Subscribe to AI-Proof Jobs to understand exactly where the real-world opportunities are hiding and build a career that technology can't touch.